Hi everyone, and welcome to the second session where we're exploring speed and acceleration. And as in the first session, we were looking at the characteristics of speed and acceleration and some of the underpinning physiology linked to speed and acceleration. We're going to look a bit in this session at how we can actually train for improving both max velocity and acceleration as well. So in this session, we want to understand the important considerations for training for speed and acceleration, and we're going to have a look at the actual training methods, give some examples of what we can do to improve both speed and acceleration. But before we get going, I think it's important just to have a quick recap of what we looked at in the last session before we start to explore some of the training considerations and training methods that we might use. Because it's important that we can link those training methods and what we're trying to improve back to our underpinning theoretical knowledge that we developed in the first session. So from what we covered in that first session, we know that acceleration and speed occur as a result of the utilization of the stretch-shorten cycle, so the coupling of the eccentric concentric movements within a muscle, and this rapid turnaround from eccentric to a concentric movement, which utilizes the development of elastic energy from that coupling of those different movements. And that's what underpins fundamentally both acceleration and speed and max velocity. We know that acceleration is characterized by a greater overall ground reaction force, but with it comes a longer ground contact time in order to be able to develop that greater absolute force compared to maximum velocity running. And maximum velocity is characterized by greater vertical forces, but also has shorter ground reaction times. So we see significantly shorter ground reaction time when we're operating at max speed compared to when we're accelerating. And so now in this session, we want to have a think about how we can actually train for different outcomes. We know that if we want to improve in different sports, then there are a different kind of hierarchy of characteristics that we need to develop that are going to influence the outcomes for that sport. So we know that for some sports there is a combination of metrics or characteristics that are important for success. For others there's fewer, so here we can see an example of cyclist legs, but obviously they're extremely strong, but they're also quick and powerful. Okay, but then we can also look at training for pure speed, and the 100 meters is probably the epitome, what we consider the pinnacle of kind of demonstration of maximal speed and velocity. So we're going to focus probably more around the use of the 100-meter run as an example, but a lot of what we talk about in terms of the training can be used across multiple sports. And we will explore that a little bit more as we go through this session. Now, in terms of resistance training, we know that we can adjust our training by adjusting our intensity, the volume of work, the speed of movement to get different outcomes. Okay, so whilst we put them under the umbrella of maybe kind of strength, we can focus on different outcomes within resistance training by adjusting some of the components that we have within training. So change our weight, we can change the speed of movement, we can change the volume of work. So if we go to developing our max strength, okay, we can have very high intensity, relatively low volume of work to develop that max strength. We can also decrease our intensity but increase our overall volume of work to increase our strength endurance. We can also use an increased volume of work to actually facilitate the building of muscle, so a hypertrophy, by significantly increasing the volume as well. But we can also focus our resistance training on developing speed and power. So by decreasing somewhat the intensity when we can focus on power, so that's a combination of the force and the speed of movement, or we can adjust to very light loads and focus purely on speed. Okay, and we're going to look at particularly max strength, power and speed, but mainly speed, because they all sit on a continuum of work. Okay, so it's important that we know that they feed into each other and they are linked together. Now, before we get into the training methods, specifically maybe like track work or lifting that we could do in the gym to develop both acceleration and speed, we're going to have a little think about some of the technical considerations that we would need to think about when trying to develop these characteristics. Okay, it's not just necessarily about how much force that can be applied or the rate of force that can be applied, but there are a number of technical considerations that can significantly impact on our ability to accelerate and to achieve higher maximal velocity. So from an acceleration perspective, when we're thinking about the start point before we start running, for example, then we need to think about our leg position. So we need to ensure that our front lower leg angle is around about 90 degrees, our rear lower leg angle is about 130 degrees. And in this phase, we're aiming for much higher horizontal forces during the acceleration phase. If you remember from the last session, during the initial start from a sprint, from block start, for example, there was a straight line from the shoulder down to the ankle. Okay, so we're trying to go from a more horizontal position into a vertical position gradually. So there's a higher horizontal force in those initial start point when we start running. There's also going to be shorter initial strides and high vertical velocities as well, in order to try and raise that center of mass so that we can get into a more upright position and to start getting towards maximal velocity. But from that initial start point, we want to keep a kind of 45-degree angle as a whole on the body and have longer ground contact time as we try to increase our velocity so that we can then move ourselves into an upright position. And now as we begin to accelerate, you also want to make sure that the swing legs are relatively low to the ground, so they're not excessive distance covered. And the aim at this point is for a higher stride rate and a lower stride length. Okay, so you see that will shift as we start to get into higher velocities, but in the initial instances you accelerate, stride rate is a bigger determinant of being able to accelerate compared to having those longer stride lengths. It's not going to be as economical in those positions to try and get a long stride length. Okay, so stride rate is what the focus should be during the acceleration phase. Now, some common errors that can be found are listed here. Now, obviously, you can read these in a lot more detail in your own time, but some key things to think about is around hip position. So if the hips are too high, it can lead to an inefficient application of force into the ground. There could be lateral movement as you start to accelerate, and obviously that's going to start to cause a loss of force as well. Start putting the forces causing lateral movement as opposed to horizontal movement. So anything that causes us to cover a greater distance is going to impact our ability to accelerate and the speed at which we can accelerate. You can also see some links to mobility, particularly around the arms. So if they're particularly short and tight, there's not getting a full movement through the shoulders. That's going to limit the ability again to maintain stability as we're running. Unnecessary tension in the neck and in the shoulders also going to impact this as well, going to be causing a limitation in the movement. Also can be push-off angle of too high, so it's kind of a jump in that first stride, okay, which is going to really slow us down. We're getting too much vertical force in that first instance, not translating into horizontal force initially, so that's going to lead to a much slower acceleration. And then finally going into an upright position too quickly. So we know to accelerate, we need that angle to be kind of lower. We don't want to be as upright to facilitate those slightly longer ground contact times, so that we can develop much greater forces to facilitate the acceleration. Now, from a maximum velocity perspective, we want to think about having our shoulders over our hips, which are over our feet, head relaxed with high horizontal forces, much shorter ground contact time, and we can also lead to a significantly increased stride length. As we start to enter into more maximal velocities, we're in an upright position, that facilitates our ability to lengthen our stride, okay, because we can get more movement through the hip, and we can reach out during those strides to facilitate the greater stride length, as well as maintaining a high stride frequency as well. And when we look at some of the common errors that we see when people are in maximal velocity or trying to achieve maximal velocity, we can see that there's some issues around trying to stay in the acceleration phase too long. So even though they're getting into a position where the shins are vertical in comparison to the floor, they're trying to maintain an acceleration position for too long, and that's not going to enable maximal velocity to be developed. You start to see some overstriding possibly, okay, trying to reach too far. And as we've mentioned in the previous session, there is a bit of a balancing act between stride length and stride frequency. We start to go into too long a stride, that's going to decrease our overall turnover, our rate of stride. Okay, so it's going to then negatively impact on our maximal velocity. So we need to find a balance between stride length and stride frequency. So sometimes when they're in max velocity running, there'll be a tendency for some to overstride and inadvertently actually slow themselves down. And then finally, we might see some erroneous arm movement. So as we mentioned in the previous session again, if we're getting inefficient movement or we're getting too much rotation, okay, that as well is going to lead to a loss of application of force. So some of the force that we're applying, rather than causing us to move horizontally, we're getting some rotation in the body. Okay, so the excess or erroneous arm movement in that plane can significantly impact our maximal velocity, so our running speed. So we want to maintain everything in effectively as single a plane as possible. We don't want to be crossing over in this transverse plane and causing a loss of energy and an inefficient movement pattern. Now, when we're thinking about how we can monitor the development of speed, obviously our main metric is the time to complete a task, but there's obviously a number of other factors as well we need to think about when we're monitoring the development of speed and acceleration. So ground contact time is a good one, something we can get from force plates, for example. And typically, if we decrease the ground reaction time and we are still able to generate the same amount of force, that would translate in a faster sprinting time. So if we're able to monitor that change and a decrease in ground contact while maintaining the same force output, then we should know that there's going to be a translation to an increased running speed. We've also spoken about the relationship of the step length or stride length. So this can be measured either between two consecutive steps, so from right to left, for example, or the distance covered by two successive steps, so going right foot back to right foot again. So we know we can improve these metrics through improving our force output and improving our mechanics and posture. But we can also look for things like asymmetry. If we're seeing particularly shorter stride length in one leg compared to the other, then we know that there's either an issue with force output or some issue with mobility, or even possibly stability on the other leg. Okay, so by measuring these, which aren't too difficult to measure, okay, do that simply with a camera and some markings on the track. But it's a simple way of being able to kind of monitor the speed development process and try to highlight where some of the development is being positive, or where we may be seeing inefficiencies within the movement pattern. Can also measure flight time. So if we see an increase in flight time, then we might see that as a result of higher vertical forces. Okay, and that may lead to some more efficient horizontal displacement, or it may be that we're producing higher forces and getting some unnecessary vertical movement of the center of mass. So if you think back to the video where we were watching Usain Bolt, we didn't see much oscillation in his overall hip height. So whilst we're applying force vertically into the ground, translating that to a horizontal movement, we don't want excessive vertical movement, because again we're starting to see an inefficient movement, and that'll end up leading to a loss of energy and therefore a decrease in velocity. And then finally, one of the other things we can measure is a stride angle. So what's the angle of the foot as it leaves the floor? If we get incorrect angles within the placement of the foot, maybe too flat-footed on placement, too much on the toes maybe, that can lead to improper sprint mechanics, okay, not an effective or efficient application of force into the ground, and that as well will translate into a reduction in sprint times. So aside from just measuring sprint time, we can also look at some different metrics to analyze how speed development is going and try and highlight where the main issues are in someone's ability to either accelerate or to reach a greater maximal velocity. So now we're going to actually look at how we can develop speed. Okay, and fundamentally the best way to develop maximal velocity is by doing maximal velocity work. Okay, if you want to be quick, then you should train quick. Okay, but obviously that's not the only way that we can develop speed, and we often as well need to develop and use other techniques to try and enhance both acceleration and maximal velocity running. As I've mentioned before, speed and power sit on a continuum with strength. Okay, so they're all related metrics, just with different amounts of force applied at different velocities. So they are on a continuum, and therefore they're all related. All these metrics are related to each other. So in theory, with a greater maximal strength, that should enable a greater speed of velocity. Okay, so a greater maximal velocity of movement. This doesn't always translate, because if you just develop maximal strength and work at slow velocities, we're not getting the development of the neuromuscular system to operate quickly. Remember, it's not just the force that the muscle can apply, but it's the rate of stimulation of the muscle and the rate of impulse. So we not only would need to develop the maximal strength component, but also the speed component as well. And as you can see on this continuum, depending on the relative intensity that we use in our training, will depend on where the focus will be. So the higher the intensity, there's a greater focus on the absolute force with a lower velocity. And as we move along into the power end of the spectrum, we see a more moderate intensity used with a greater focus on speed and movement. And then as we go along to speed strength, speed velocity, again we see a decrease again of the intensity that would be used, but much greater focus on the velocity of movement. Okay, so depending on what aspects we want to develop, whether we're looking to develop just maximal speed or maybe acceleration, then we can adjust our intensities to try and reflect that, to see whether the focus is more on about absolute force development, or whether the focus is more on the development of higher velocities but using a lower intensity. And as I've mentioned, there is a difference across short speed acceleration and maximal speed in terms of the importance of different qualities. So we can see in this table here where we look at the relative importance of leg strength and of speed strength qualities in the short sprint, so around 10 meters, which is obviously a focus on acceleration, or whether we're looking at maximum speed, which obviously takes a lot longer time to develop. And we can see that for the short sprint, the general speed strength and the relative maximal strength are most important compared to the maximal speed, where again the general speed strength is important, but also the reactive strength. And this is highlighted by the shorter ground contact times that we have during maximal speed running. So that's why it's slightly less important in the acceleration phase of running, but the general speed strength and the relative maximal strength, because we're developing and applying higher absolute forces in this acceleration phase, remember, compared to the maximal speed phase. And we're also having shorter ground contact times in this maximal speed, therefore highlighting the need for a greater focus on the reactive strength for developing that factor. Now, when we think about resistance training for developing speed, typically we would think about operating at much lower intensities, so very light to no resistance, maybe just body weight. And typically this would be in low rep ranges with moderate number of sets. So the lower rep range is sort of 4 to 6, but sometimes even lower. The number of sets around 4 to 5, but the main focus is on high speed movements. And every action performed within a session, a resistance training session that is focusing on speed, the focus in any exercise should be on high speed movements. But whenever we're applying high speed movements and high intensity work that comes from those high speed movements and the utilization of the stretch shorten cycle, typically that would lead to much greater muscle damage. Okay, and therefore a greater need for recovery to be factored in, both between sets and between exercise sessions. So the high neuromuscular demand that comes from this type of training, whilst the relative load might be quite light, the dynamic actions that are incorporated and the utilization of the stretch shorten cycle would ultimately mean that there's a greater amount of muscle damage, and therefore we have to factor that in when prescribing this type of training and enable sufficient recovery before the next session. We don't want to be doing these sort of sessions fatigued, because that's when we start to end up with greater amounts of injury because the muscle hasn't fully recovered yet. So it's important that recovery is factored in for this type of training. And now when we're thinking about actually trying to increase speed, there's a number of methods that we can use. So one way is to use a technique called speed overtraining, and this would be where you might use ropes, large rubber bands, or even downhill running to increase the maximal speed that someone is able to achieve. And what this is designed to do is to promote the neuromuscular adaptations that are necessary to enable a greater maximal speed to be developed. So it's almost getting the body used to operating faster. Now, obviously, sometimes this can come with some limitations. So the use of downhill running particularly can change the running mechanics and posture, which may not translate when it actually comes to applying it on the flat. Sometimes, again, with the use of ropes or bands, they can be too strong, particularly bands, and again, it can pull people out of their normal running mechanics. So it's something that is beneficial and can facilitate this neuromuscular development and getting the body used to moving faster, but we do have to be aware that it can interfere with the normal running mechanics, and so it has to be something that is applied quite carefully and wouldn't be necessarily something that is utilized all the time, but does certainly have some benefits and can help to develop maximal speed running in particular. And another method that we can use to develop speed is speed resistance training. So actually providing a resistance when someone is running. And you can obviously increase the load that they're dragging, but you can use parachutes, you can use sleds, you can use ropes and bands to provide a resistance for someone to sprint against. And it has been shown to increase muscular power, but as you can probably notice from all the pictures on the slide here, all of the people running are in a position that would be more greatly associated with the acceleration phase. So these methods are probably best used for developing acceleration capabilities. So you can see we're already in that forward lean and using that triple extension. So they are a very useful method, but probably most effective at developing the acceleration capabilities. Now you can also see at the bottom here where it's got it resistance cables on each limb, which can be used, but again we have to be careful that this isn't going to interfere with the actual running mechanics of the individual. So we want to make sure we're maintaining good mechanics, good posture as they run. So we do have to be careful in the application of these and making sure we're not putting too much load and too much resistance for them to run against, because again this will interfere with their overall running posture and running mechanics, and that in the long term would be detrimental to overall performance. When it comes to knowing what load to use when we're applying resistance training for speed, then we can see from these tables here from a study from a few years back how we might adjust the load depending on the size of the individual, the impact we want on the actual maximal velocity would be developed, and also whether we're trying to train maximal velocity or whether we're trying to develop acceleration capabilities. So you can see that with a higher body mass, we would typically have a greater amount of weight resistance. Okay, still not huge, but around kind of 10% body weight for most people to get a 90% maximum velocity. And then we would obviously decrease that weight depending on how much of an impact we want on the maximal velocity. And if we look across, we can see that that is slightly higher in most instances for the acceleration capabilities that we're trying to develop. Okay, so we can see that trying to get 90%, then would be a much higher overall weight that we would be using to impact on that. Because remember, for acceleration, it's about the maximal force that we can apply through the floor as we're accelerating. So the ability to develop a higher relative overall force will be beneficial during that acceleration phase of any run. So we're now just going to have a little look at some actual examples for developing the different characteristics of speed. So we can see here, if we're trying to develop acceleration, relatively low overall volumes Okay, only one set of 3, one set of 4, 15 and 20 meters. Obviously, if we're developing acceleration, then we know that the acceleration phase for any run is probably up to a maximum about 30 meters, depending on the level of the individual, obviously. But so we would be using relatively short distances to develop acceleration, relatively low overall volumes, and might also incorporate the use of incline sprints or hill sprints. So by utilizing some kind of incline, what we're doing is getting the body naturally into the accelerating position. So we're already getting a forward tilt in the body to try and kind of mimic the position we might be in when we're accelerating. Obviously, if that incline is too great, then it's going to negatively impact on our ability to actually sprint. But having some form of incline that lends itself to getting us into that accelerating position would teach the athlete how to kind of get in that position quite naturally. And then for the second session, again, we can see relatively low overall volumes and relatively short distances. We do have to remember these low volumes are there because of the relatively high neuromuscular demand that comes from this type of training and the high amounts of damage that it can inflict on the muscle. Now, as we try and extend out our acceleration capabilities and develop the ability to accelerate up to sort of 30 and 40 meters, you can see again that we keep in relatively low overall volume in the training, but a slight increase in the distances used. Still not particularly high, but starting to push out towards the kind of top end of where we can accelerate to. You then might start to see introduction of some resistance elements, so using something like a sled to further develop these acceleration capabilities. Remember, those sleds help get you into that accelerating position. They get that forward lean because of where the positioning of the strap is, and also providing that resistance will lead to a slightly longer ground contact time and the higher development of force. So getting the individual used to developing higher amounts of force that they have to overcome in order to obviously run that distance. And then finally, again, just making use of a range of distances, so still maintaining that early acceleration work, but then also starting to continue to develop the longer acceleration capacity. Now, as we start going into looking at to develop maximal speed and still trying to maintain some of the acceleration capabilities, you can see that we're starting to increase the distance and also shifting into more like block starts. So again, trying to maintain this acceleration capacity and getting the athlete used to going from those low positions and getting into the acceleration phase and the acceleration positions that we need. But then start to develop some high stance starts, so getting into the max velocity running position from the get-go, but also utilizing flying starts, so using some distance to build up speed so that once they get ready to enter into the maximal velocity running for around 20 meters, they've already gone through that acceleration phase so they can get into the correct body position for maximal velocity running. And then finally, you can see the third session there is a combination of maintaining the shorter acceleration components, the longer acceleration components, whilst also going into the high velocity running positions for a longer distance. And then finally here we see a much bigger focus on maximal speed running. Again, we still see some shorter distances being used in the initial phases in the early session, utilizing block starts and more acceleration positions for these shorter and longer acceleration components. There's then, again, the use of the high stance starts and the fly float start as well, which is a way of going from a kind of maximal speed into more of a coast and then back again into a maximal speed. Okay, so utilizing some of the momentum through this float phase, which is essentially a fast cruise, before entering into the maximal velocity phase. And again, in that final session, we see a combination of these shorter and slightly longer acceleration phases, whilst also then going into our longest kind of sprints. Remember, we're probably reaching maximal velocity at around 60 meters, maybe 70 meters in a 100 meter race. So then we're starting to build on just maintaining maximal velocity and speed endurance and try and minimize the drop off in maximal velocity that you would inevitably see once you've reached max velocity. Now, as we mentioned earlier, there's obviously a connection between maximum strength or the maximal force that can be developed at lower velocities and our ability to develop force at higher velocities. So you can see on this figure here that in theory, if we're able to shift this curve and increase the absolute force that we're able to develop at lower velocities, in theory that should translate to an increase in the force output at higher velocities as well. Obviously that means that we have to combine a number of methods of training in order to enable that, but the main component, or the first component we need to develop, is this maximal strength component. And in order to do that, we have to use very high intensity loads, so anything around 85 to 100% of 1 rep max, and a much lower overall volume of training, so much lower rep ranges we'll be using, say 1 to 5, an absolute max, relatively high sets in order to get sufficient amount of training and overload into the muscles. But as we mentioned with the speed training, we would also need much higher or much longer rest periods for this type of training. So between sets, over 2 minutes if not more, but at least 24 to 48 hours between sessions because of the really high neuromuscular demand that is placed on the body during this type of training. Now, it's also important for us to remember as well, there's no focus on speed of movement in this type of training. So whereas in the speed training or power training, then there will be a much greater focus on the speed of movement, okay, to develop those neuromuscular components, whereas here, for just developing the maximal strength, there's no focus on speed at all. And I just wanted to highlight here the link between different metrics of speed and absolute and relative strength. Okay, so here they've taken absolute and relative strength measures using a squat in young footballers, and you can see there's a correlation with a number of different factors here. So not only strong correlation in the jumps, both squat jump and counter movement jump, but also strong correlation with the sprint times that they assess here, just demonstrating how both absolute and relative strength can then translate to performance benefits for speed and acceleration. And then the final factor we want to think about is our power training. So remember, we sit on this spectrum from max strength to speed training, and power sits somewhere in the middle as a component of both, requiring high force but also high speed. And in this type of resistance training, we would use relatively light to moderate loads, but it depends on which side of the power element we would be focusing on. Okay, if we wanted to go a little bit more strength focused, maybe more developing around acceleration capabilities, then we might slightly increase the load compared to if we're focusing on speed and speed of movement, where we're on the speed strength side of power. So there we might drop the load down somewhat so we can get a higher rate of movement. Again, we're using relatively low rep ranges and sets as well. Don't want to have too much volume. Again, so keep going through. There's a high neuromuscular demand from this type of training, so we have to keep overall volumes relatively low. But again, the focus really is on high speed movements in this. Okay, so whilst the movements might be slightly slower compared to just pure speed work, the focus is still on the speed of movement. So even though the capacity to move quickly may not be there, there should be an intention to move as quickly as possible. Okay, unlike maybe with max strength, where it's just about getting through the movement, here there should still be that intention to move quickly, even if not able to. And in order to develop our power, typically we would need to have a base strength development, as we've mentioned in the previous couple of slides. So developing a base of maximum strength before then converting that to the movements that we want and trying to facilitate a high power to weight ratio. So being able to exert high amounts of force quickly, and the more relative power we have, the better placed we are for developing both acceleration and maximal speed. And one of the final methods that we're going to look at for developing speed is the use of plyometric work. And this is any movement that effectively makes use of or utilizes the stretch, shorten cycle. So this includes jumping, bounding, drop jumps, whether it be single leg, double leg. And the key factor is that it utilizes the stretch, shorten cycle, moving from an eccentric movement into a concentric movement. And that's a really great way of developing the capacities for both acceleration and speed. And we'll look at this a lot more in the third year. We'll go into a lot more detail, but essentially if we try and develop plyometric work, we'll move from a more stable base to a less stable base, obviously trying to reflect the instability that comes from high velocity movements. And the plyometric progression might go from maybe a non-counter movement to a counter movement, jump or bound, then going into, rather than single contacts, going into double contacts, and then into multiple contacts, again trying to replicate this cyclical nature that we would get in running, for example, and getting used to engaging that stretch, shorten cycle on multiple occasions again and again. So it's just one way that we can progress plyometric work. And then overall, when we think about our progress of training, as I mentioned previously, we want to make sure that we develop a max strength base before we start moving on to developing our power components. Okay, before then finally going on to developing our reactive strength components, which are fundamental for both acceleration and speed. So when we're trying to improve acceleration and speed, okay, if we're not in season, for example, we might be able to have a focused amount of time where we can develop max strength, okay, before then starting to go on to a phase of power work, okay, where we start to get a greater focus on the speed of movement rather than just the absolute forces that we can develop, before then finally going on to developing that reactive strength and that speed strength, where we would utilize much lighter loads and again this greater focus on the speed of movement. Now, how we might progress this training might be dependent on the type of sport that we're training for. So if the sport is determined purely by speed, so for a 100-meter runner, for example, then our greatest focus eventually has to be on this reactive strength, this speed strength at the end of the spectrum. Doesn't mean we wouldn't still utilize the max strength and the power work, but ultimately our main focus would be on that maximal velocity and that reactive strength. Whereas some other sports, the focus may be more on the acceleration component than the maximal velocity that they can be achieved. There might not be the capacity to reach maximal speed in that sport, whether that could because of the rules of the game or the size of the pitch, for example, or just the characteristics of the sport. So therefore, we may not focus as much time on the reactive strength and instead focus more on that power component to really develop the acceleration capabilities of that individual. But again, a lot of this is dependent on the needs of the athlete as well as the demands of the sport. And so just to finish off, just got some key points that we want to take from this session. And that's that if we're trying to develop speed, for example, we need to use the development of things like max strength as a base before we can start developing power and speed. But each period of training should build on that previous one. So if we're developing max strength, then we want to use that first before moving on to power and speed. And in order to adjust for those different outcomes, then we need to think about the interaction of the training load and intensity, and also the speed of movement that we're utilizing within any action. And then finally, we need to remember that if we want to become faster, then we need to do things quickly. Okay, so if we want to become quicker at running, then ultimately we need to get that individual running faster and training to run faster. Okay, it's the best way of actually getting faster and improving our max velocity and our acceleration. Okay, so that brings this session to an end where we've been looking at speed and acceleration. Obviously in that first session we looked at the characteristics of speed and acceleration and some of the underpinning physiology that we would need to tap into. For this session where we've been looking at how we can actually train those elements for an individual. So how we can train for speed and acceleration. So as always, if you do have any questions, please feel free to get in touch and I'll obviously be happy to answer any questions you have. So till then, thanks for listening. Cheers. So some fundamental movements that we have within maximum velocity running. We have this early flight phase. Okay, so we get this eccentric hip flexion and an eccentric knee extension. In a mid-flight, we get the concentric hip flexion, followed by the eccentric knee extension into a quick eccentric knee flexion again.